No, you don't have to, no. All right. Well, anyway, what I'm going to do is you're going to see me do this chapter a little bit differently than the author does it. If you read, when I get done with my lesson, you read the lesson in a book. If you do that, you'll say, oh, that's kind of the same thing. I just do it in a little different order than the author does, and I think it makes more sense to me. So what I'm going to do here is we're going to start with this chart here. And have you ever seen this chart before?
Yes.
What is it? Oh, you've seen it? Okay. Okay. All right. So this right here, I've taken lots of science classes. When I was in college, took a lot of them and stuff like that. Pretty much every science class I've had some reference to this chart. And they may not have shown that chart. That chart, actually, they have one in your book, something like it. So I'd like to take a look at it. And I'm going to use this as a foundation. Like if I was going to build a building, I'd have to make sure the foundation was there. You get that? And the foundation is strong. And then all of a sudden, you can build things on top of the foundation. So what I'm going to do here is we're going to spend a little time with this today and a little bit tomorrow. And then that's going to be a foundation. And I'm going to trick you. I'm going to show you that if I teach this to you, then all of a sudden, when I teach this part of the chapter, it's easier because of that. I'll teach this part of the chapter, it's easier because of that. So you have to trust me, don't you? So I'm asking you to trust me on this. Can you get it? Okay? All right, here we go. All right, everybody see this chart? Now, this is called, what they call powers of 10. Now, that's not multiples of 10. Multiples of 10 are 10, 20, 30, 40, 50. Is that right? These are powers of 10. And so you know that means exponents, doesn't it? Yes, no? Yeah. All right. Now, powers of 10 is a framework that's used in science a lot. A lot. Now, what I'm going to do here, we're going to start here with this number here. Everybody see that? That's pretty easy. Notice that if they were to take that number and simply move it over here, is this bigger than that? Yeah. Just because I moved the 1 over here, all of a sudden it's bigger? But how many times bigger is it? 10. Let's move that 1 over here. Let's move it again over here. Does that make this number bigger than this? Yeah. How many times bigger is this number than that? 10. But how many times bigger is this number than that? Whoa. Whoa. Okay, let's move that 1 over here. Does that make this number bigger than that? How many times bigger? And how many times bigger than that? This is than that. And how about this and that? No wonder we call it 1,000. It's 1,000 times bigger than 1. Okay, now here we go. Here we go. Ready? Can you stay with me? I start out simple. I always start out simple. Can you close that door for me, please? Now look what happens. I'm going to move this 1 over here to the other side of the decimal. Does that make it bigger? What? Did it make it smaller? How many times smaller? What? It's 10 times smaller than that? Okay, let's move the 1 again. Is this smaller than that? Yes. How many times? 10. But how many times smaller is this than that? 100. That's right. Now, I'm going to start out simple, but don't let me lose you, okay? Everybody ready? Yes. All right, you ready? All right, I'll try to make a little mark. I'll try to call on everybody. So let me make a mark so I'm not leaving anybody out. Will, you're first. Will, ready? Let's play a game, Will. Will, ready? How many times bigger is that than that? 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 How many times bigger is this 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 than that?
100.
Oh. Wait a minute. How many times bigger is this than that?
100.
Wait, how many times bigger is this than that?
0.10.
Wait, everybody stop. How many times? You'll have your turn. Everybody have your turn. Will. How many times bigger is this than that? How many times bigger is this than that? How many times bigger is this than that? Now, here's what some of you don't understand. There's a very powerful pattern here, isn't there? All right, let's go with, Abby Rose. Abby Rose. What? I just randomly picked a student.
No, you're just cheering for her.
Oh, okay, ready?
Good luck.
Ready? Abby, ready? Okay, hang on. Ready? How many times bigger is this than that?
10,
How many times bigger is this than that?
100,
How many times bigger is $1 billion than $1 million? Everybody stop. How many times bigger is this than that? No, stop.
oh, 10.
Stop. Don't listen to anybody, okay?
I'm not.
How many times bigger is this than that?
10,
How many times bigger is this than that?
100,
How many times bigger is this than that?
1,000,
So $1 billion is how many times bigger than $1 million?
1,000,
That's right. Got that? Ready? How many times bigger is this than that?
10,
How many times bigger is this than that?
100,
How many of these does it take to make one of those? Wait, how many of these does it take to make one of those?
10,
How many of these does it take to make one of those?
10,
How many of these does it take to make one of those?
10,
No one's ever asked you that in your life, have they?
no,
And you got it right, didn't you? There's a powerful pattern here. Are you with me? Now the questions can get harder. Just stay with me, okay? All right, Fiona. Fiona, how many of these does it take to make one of those? How many of these to make one of those? How many of these to make one of those? How many of these to make one of those? How many of these to make one of those? Okay. How many of these to make one of those? How many of these to make one of those? Yes. How many of these does it take to make one of those? Okay, is everybody with me? If you'll let me teach you this pattern, I can trick you into learning some other things in science. You get that? It's not really a trick. All right. Brown one. Ready? Let me just see if you're paying attention, okay? How many of these does it take to make one of those? How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many of these does it take to make one of those?
10,
How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
All right. How many how many $10 bills would you need to buy a? How many $10 bills would you need to buy a $1,000? What's it? What costs $1,000? You got?
A Toyota.
No. What would you like if you had $1,000 and I said you had to spend on something? What would you,
iPhone 13.
iPhone? Okay, ready? How many $10 bills do you have to save to be able to buy a $1,000 iPhone? Yes, right. Keep going. How many pennies would I need to buy a $10 pizza?
100,
Okay, let's take a look. Where's penny at? Is this a penny? What is that? How much money is that? $1. How much money is that? A dime. How about that? Isn't a dime a tenth of a dollar? Isn't a penny a hundredth of a dollar? How many pennies does it take to make to buy a $10 pizza?
1,000,
10, 100, 1,000. You're right. If you had 1,000 pennies, you can buy a $10 pizza. Now, no one's ever asked you that question, and before today, you would have had some other way that you would try to figure it out, wouldn't it?
Yeah.
But it's actually kind of simple, isn't it? All right, you did a good job. Let's go with Lily. Lily, let's see. Lily, how many of these it take to make one of those?
10,
How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many of these it take to make one of those?
10,
How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many millimeters does it take to make a centimeter?
10,
How many millimeters to make a decimeter?
100,
How many millimeters to make a meter?
1,000,
How many millijoules to make a joule?
1,000.
Yes. Has anybody ever asked that question in your life, ever? No. You see, what I'm trying to show you here is there's something you may have said I don't like, and there's no way you can tell me you don't like it. You can't tell me that I don't like the metric system because what? If you can tell me how many dimes it takes to make a dollar, you can tell me how many decimeters it takes to make a meter. You can tell me how many deciliters to make a liter, how many decijoules to make a joule. You said, but I'm not sure what a joule is. It doesn't matter.
What's a joule?
It doesn't matter. Joule is an energy unit. Even if you didn't know what a joule was, it takes 10 decijoules to make a joule.
Yeah, those aren't good.
I noticed that there's no way you could say the metric system doesn't make sense because you use this number system. This is the number system you use in your mathematics. This is your number system. Thomas Jefferson, the third president, he decided that United States would do something that other countries was not doing. He understood that not all the money, but he wanted to make a money system based on powers of 10. And that's why you can say how many dimes it take to make a dollar, and it works. How many pennies to make a dime? It works. Now, for convenience, they had to come up with things like nickels and quarters and $5 bills, but the main money system is based on this chart, powers of 10. Right before 1800, a group of scientists in France, the French Academy of Sciences, they said, we need a measurement system that every time I read about an experiment done in Germany and England and somewhere else, I'm always having to convert because their measurement system is different than ours. And they're having to convert. And it's tiresome. And so he said, what if we made a measurement system that the entire world would throw away theirs? Are you kidding me? That'll never happen. Oh, it did. They said, let's make a measurement system that is so easy to use that every human on the planet, eventually, every country will throw away their number system and adopt this one. Who in the world would have thought like that? And they did. And the metric system was based on powers of 10, the same system that our number system was based on. That's why everybody did it. We're essentially the only country, there's one other little one, we're essentially the only country that by law doesn't use a metric system. Now we use a metric system. I just bought some 2-liter sodas the other day. I bought 2 liters, didn't you? And some of you on track, you run 100 meters, don't you? So we use the metric system, but by law, we don't force everybody to use it. Not too long ago, they made a law and said, if you have a product for sale, you must have both kind of measurements on there. That can of beans has so many ounces and has so many grams. Now, you know why they didn't mind? You know why the United States didn't mind that law? A lot of people in the United States didn't want to make a law and say, you will all use a metric system. They didn't like that. But you know why it was okay when they said every product you make has to be branded, it has to have both measurements on it? Because guess what? If you make pork and beans and you want to sell them to somebody in England, you can't. In France, you can't. You can't sell them anything that doesn't have the metric unit on it. So did it hurt the business people to say, let's put grams on there? No, it helped them, didn't it? So humans are kind of like that. You tell me how I can benefit, and I'll do it. Yes?
What's the other small country that doesn't use it?
Let me look. Let me think. I forgot. There are actually 2, and one of them switched over, so now I got to remember which one. Wait, I'll show you just a minute. What countries do not use the metric system by law?
Here's what I found.
All right, here we go. There it is. I thought it was. Have you ever heard of Burma? Okay, a lot of people who live in Burma, they want their country to be called Burma. The most recent government, though, that took over, they want to be called Myanmar. Have you heard of either one of these names?
Myanmar? Is it like near?
Okay, so Myanmar, also known as Burma, and the United States. There you go. Don't you feel proud?
Is that near?
Don't you feel proud?
What do they use?
I'd have to look that up. Now, all right. Let's keep going with this chart here. I want to show you some other things. Ready? Let me. I talked to Lily. Let's go with. How about Reese? All right, Reese, ready? Let's see if you still remember the lesson. Reese, how many of these does it take to make one of those?
10.
How many of these to make one of those? How many of these to make one of those?
Oh.
Hold it. It's frozen. Okay. All right, ready? How many of these does it take to make one of those?
10.
How many of these to make one of those?
100.
How many of these to make one of those?
1,000.
How many micrometers does it take to make a millimeter?
10,000.
So 10, 100, 1,000. How many?
1,000.
1,000. So how many micrometers to make a millimeter?
1,000.
How many microliters to make a milliliter?
1,000.
How many microliters to make a liter?
So
100,000.
Almost.
Oh, 1,000.
10, 100,
10,
1,000,
100,000, 10,000, 100,000.
trillion.
million.
What?
Now, one more time.
Wait, what?
That's a million.
It takes 1,000,000 microliters to make a liter. All right, Reese, how many micrograms does it take to make a gram? How many microjoules to make a joule? You see? Everybody see this? The pattern is so strong, they used it to form the basis of the metric system, didn't they?
Yes.
You can't say it doesn't make sense. You can't. You use this same system in your money system and your number system. Why can a first grader tell me how many centimeters are in a meter, and you go here and they can't? Everybody in the world can tell you how many centimeters are in a meter because they start them early, don't they? And it's very simple. It's simple. However, the whole world get rid of their measurement system that had been used for a couple thousand years to adopt this one. It was simple. You with me or not?
Yeah.
Okay, now you have to believe in what I'm doing here, all right? Now, what I'm going to do is, when I first start teaching this, I do what they call the underhand serve method. And the underhand serve means it's simple. The ball probably will go over the net. You get it? But by the time I get done, in the next couple of days, all of you will be doing jump serves. So I'm going to show you how to get it over the net. You say, well, at least I know how to do the problem that way, and then I'll have you do a little more advanced thinking. How about that? So we're not ready for super advanced thinking yet. All right. Now, wait a minute, before we go any further. So, these things here, these are called prefixes. And these metric prefixes, they simply belong to a power of 10. Now, you have to memorize these. Now, some of you did a good job. Some of you used flashcards to memorize elements, didn't you?
Yeah.
So you're going to have to do some way. Maybe you can use Quizlet. But you have to memorize these prefixes. So let's see if we have some. Let's see if we can figure out some way of doing this. Now, it's very, very possible that in middle school, they probably had you learn these. Is that correct? Elementary?
Not only like the first first three, not the
I meant
top three.
not the bottom three?
No, not the top three.
No? Okay.
No, we have to do
Okay, so let's, did you have something like this, a memory trick to remember these, or?
Or kilometers, 1,000 miles.
Yeah, but did you ever do like King Henry died at
Yeah.
drinking chocolate milk?
Yes.
Did you ever do that?
The chocolate milk. Yeah, the chocolate.
I don't know. You can make up your own little memory trick. You get that? Here, King Henry died at drinking chocolate milk. Okay, I could do that. Now, I do notice that, and I think everybody should have those 6 down very quickly. Now, this one, notice that they got out of the small letter prefixes. Once you get to 1,000,000 and higher, What kind of an abbreviation do you use? Big capital letter, don't you? Now, another thing is, these are prefixes. There's no such thing as 5 centis. You can't have 5 centis. You can have 5 centimeters, 5 centiliters, but there's no such thing. A prefix never stands alone, does it? That's why I have this little dash after it. Big M dash. It's a prefix. You got to put something after, don't you? Now, mega, in our state, whether you agree or not, we have a lottery, and it's called Mega Millions, isn't it? And so Mega Million, that's an easy memory trick for me. Mega Millions. Now, this one, I don't have a great memory trick for this. Giga is a billion. So I don't have a great memory trick for that. I just have to memorize giga is a billion. And then tera trillion. I think I can do that. Tera trillion, I can learn that. Notice that these are all capital letters, aren't they?
Yeah.
Now, after we get past King Henry died, drinking chocolate milk, now we go down 3 more. Now look at this one right here. This stands for micro. And it was so small, you had to have a microscope to see it. So I know micro is small, isn't it? As a matter of fact, micro is not 1,000th, but 1,000,000th of anything. Okay, look right here. Hold it. This symbol here, micro, starts with an M. Why didn't you use little m as your prefix? Sorry, it's already been used. Why don't you use capital M? No, capital M means for really big things. Well, then what am I going to use for the prefix for micro? It starts with an M. I'll go to a different alphabet. I'll go to a Greek alphabet and use the letter mu, which is M. And this right here is a mu. I'll show you how to write it. You write a U, and you put a tail on the front, you go, whoop, and you make that noise. So let's try that. Ready? Let's try it again. Make a U, go to the front. Okay, that's how you do it. Now, when a typewriter does it, it kind of looks like this. So when a computer does it, it looks kind of like this.
Does that say magnet?
Thank you. And this is called a mu, okay? Thank you. A Greek letter mu. Everybody got that? So mu stands for micro. Let's go on down. And nano. Nano means not 1,000,000th, but 1,000,000,000th. This is nano. And then I'm going to skip this one for a minute. And then down here, pico is even smaller. That's a trillion. Now, believe it or not, in science, there are some things in this planet that we have to measure. For example, a picometer. I don't have to measure picometers, but there are people who are measuring things really, really tiny, like the size of atoms, and smaller than atoms. And they use picometers. I don't use picometers. Everybody got that? Okay. Now, what I'm going to do is I want you to memorize these prefixes, the ones I've shown you so far. That's your first goal. Now, I also want to show you some other patterns. Let's go over some other patterns here. Get that? Let me see what time it is.
I think it's 11:20. It's 11:20.
Okay, on Tuesdays, we have 2 more minutes. Okay, now, picometers are actually smaller than the diameter of an atom. So if I were using like the size of a proton, I might go down to picometers, something like that. I'll show you another one. There are other things on this planet that are harmful. And we have things like radiation. There are some things that are so radioactive that you don't want, even a little tiny bit of it can hurt you. And so, believe it or not, humans actually have a device that can measure picocuries. Now, picocurie is a radiation amount of radiation, and some things are so radioactive that even a few picocuries can be harmful to you. So humans have actually figured out how to measure something that's a trillionth of something. If I had a trillion pieces of air and one of them was radioactive, I could measure 1 picocurie in there, 1 out of a trillion. All right, so tonight, if you have lots of other work, I understand not doing any chemistry, but I could at least see you making flashcards on the prefixes. That would take very little time to do that. And all right, well, thank you.
Thank you, Mr. Keenan.
All right, you're welcome. Oh, I have you want one of those? It's on that desk back there, and I'm gonna review everything we did today. I'll do it again tomorrow, and I have it on the video.
Okay.